transition, there we go. Good evening, everyone. My name is Jeremy Carty. I am an educator here at Copernic Observatory, and tonight we have a special program on the winter skies and what you can look out for this season. So a couple of things I want to share with you before we get started. First thing I want to mention, and if you've been to our programs before, you've definitely seen that intro screen. It's incredibly relevant tonight. That program that you saw at the beginning while you were waiting for the stream to start is called Stellarium. And if you go to stellarium.org, the person in the chat for Copernic will post that link. If you go to stellarium.org, you can download a free program, a free planetarium program that will let you explore the night sky at your location or others if you want to see what else is out there. And you can change the time as well, the date and time. It's sort of a time machine. So you can really check out what's going to happen in the sky over days, months, and years. So check that out. With that said, I'm going to switch over to browser here. And this is our YouTube channel. I want to thank you all for, I think we just passed 2,100 subscribers, even just an hour ago, I think I saw it was. So I want to thank you all for supporting us, and we're going to keep these programs going. In fact, over this week, including today's program, we have 3 programs in total. Tonight, of course, is on winter skies. Our next stream is going to be a watch party for the Mars 2020 rover Perseverance landing. So watch that along with us. We'll be there to answer questions, and we'll tune in and see. We probably won't be able to get any images back immediately. It takes a while for those to come back, but hopefully you'll get some good information on when to expect those during our watch party. And then we have the Winter Star Party on February 19th on that Friday. It starts at 6:30 p.m. and if you go to our website, we have a full schedule of events. This is copernic.org, full schedule of events to check out. This includes talking about the life of, because this is actually in celebration of Nikolai Copernic, or Nicholas Copernicus' birthday. So we're going to talk about who Copernic is named after. And then we have a program from Robert Nye. He's a freelance writer for the Sky and Telescope. And it's the mystery SETI signal from Proxima Centauri. That's his program. We have another one titled Eyes on Distant Asteroids, Studying Space Rocks with Ground-Based Telescopes. And that's Dr. Linda French, a professor from Illinois Wesleyan University. And of course, we can also observe the night sky if it is in fact clear, and if it is not negative 20 degrees or something. I'll do my best to get the telescopes going that night too. If not, maybe I'll try and get some pre-recorded footage. We'll see what happens there. Of course, I also want to thank Broom Pediatrics for sponsoring the program tonight. And these programs as well, including Winter Star Party and the Perseverance. So you can go to our website to find more of program details in the future. And they'll also premiere on the upcoming live stream section of our channel. So with that said, let me just get one thing set up here. Here. Okay, so I'd like to introduce tonight's presenter. His name is Robert Burns. He's with our Copernic Astronomical Society, and he's going to be talking about the winter skies this evening. So I'll bring up the webcam if you want to step in here.
Hello there. As he said, my name is Robert Burns. I'm with the Copernic Astronomical Society. I've been coming to Copernic since I was a child, and I love being here, and I'm so happy to be an adult so I can actually be part of this and do things like this and share my interest with everyone. Is there anything that you need to do now, or?
We can just switch over to the presentation, and I'll let you go from there.
Great.
Let's transition here and here.
There we go.
Okay,
Great.
you are good to go.
All right. So good evening, and thank you for joining us for this presentation of the viewing the evening skies during the winter and into early spring. We start our presentation like we normally do with a little bit of a review. Let's see if this is going to work for me. Yes. So, during the winter, our nights are a little bit longer and the temperatures are colder. And both of these make viewing the night sky a little bit more enjoyable. The quality of our viewing is improved normally during the winter as our skies are clear and the cold air allows the stability for us to view the stars. In my opinion, the winter constellations are a little bit more interesting to look at as well. And it all comes down to where we are in the universe as, let's see if that's going to run or not. Here we go. As we move through the seasons, we are not only rotating around our star, obviously, but we are also moving through space, and our point of view does change. There we go. This part of our orbit around the sun allows us to be looking out and away from the center of our own galaxy. In the summer, that is our night sky. We look towards the south and we see the center of our Milky Way galaxy. So not only do we have the more daylight, so our nights are a little bit shorter, but we are looking as if into a city with thousands of lights. And it's very hard to see one particular light for especially us backyard observers that don't have great big telescopes or just like naked eye viewing the night sky or binoculars. In comparisons, here in the winter, we are looking into the darkness of space, the outer areas of our own galaxy, and we get to see some brilliant deep space objects, and some of those are even visible with our naked eye. And that's what we'd like to talk about tonight. Our rotation that we do pass through causes a lot of our observable patterns. It's our day and night, the changing length of our day, the different phases of our moon, and the different stars we see. Approaching here soon, the 20th of March, is what is called the vernal equinox, or the spring equinox. The equator will line up where it will have a full 12 hours worth of daylight on that day. Both in the fall and in the spring equinoxes, that is the 2 days of the year that everyone pretty much receives exactly the same amount of sunshine compared to darkness. And again, that relates back to our position along this path. The staff member who's going to be able to post some links, I hope can post a link for me that you can go to, skymaps.com. For people who have visited the observatory before, this should look pretty familiar. We normally hand these out right at the door when you walk in. It is a very simple to use, very informative, free publication that you can get from that website. Copernic does not have any type of cooperation with them other than the permission to print a large amount of these maps. When you look at these maps, there's a couple things that I'd like to point out. The idea that the east and west are backwards is because the paper is supposed to be held while you are looking south. So if you were to hold that piece of paper in your hands and your body is facing south, the east and west would be properly aligned. This is true for almost all publications of star maps, star charts, applications that you might be able to get onto your phone. And you'll see things that are common among them. And when you know these simple three terms, it is easier to help you direct others to see what you're looking at. At the center of this page is a little tiny X. If you can see my cursor moving, that X in the center marks what is normally referred to as the zenith. On this particular publication, of course, the word is not there. Your zenith is what you perceive as what is directly above your head. It is directly above the observer anywhere on Earth. So obviously my zenith and someone's in California is going to be two different things. But we're talking about the projection, what you see while you're standing there. If you were to draw an imaginary line from that zenith straight down to the compass bearing of south or north, that imaginary line that's passing over your head is called the meridian. And everyone uses the idea of the meridian, probably without knowing it. The abbreviation AM and PM, anti-meridian, post-meridian, talks about that. It is the sun, approaching noon is all anti-meridian. As it is directly overhead, it's noon, it then becomes post-meridian, PM. So if you think of the idea of simply the sun rising, going up to noon, and passing over, the sun has passed its meridian. The star charts and publications may talk about things crossing the meridian. And all you need to do is just imagine that path of the sun. That path is labeled, again, here on the star chart, I'm moving my mouse, with that line called the ecliptic. It again is a observed pattern that we see by chance of the path of the sun, and because of the plane of the planets, Mars and all the other planets in our moon will pass along this same ecliptic line. And if you see here again, I'm circling it with my mouse, is Mars. The constellations that are behind that ecliptic make up our 12 zodiac constellations. So here's Gemini, Cancer, Leo. If I go backwards, Taurus the bull, and here's Pisces. So a constellation that is along that ecliptic line is a zodiac constellation. And we zoom in here into that map a little bit further, and we can see the detail that is there, and it may be a little bit easier to see. The constellation Orion, these little circles, M42, here's one that says Pleiades if you see my mouse. These are different objects that are going to be viewable, and they are referenced on these star charts, over here about what's viewable. The back page of this will have a whole list of nice targets to look for too. And it breaks down the targets on a level of how easy is it to be found. Can you see it with your naked eye? Do you need to use binocular? Do you need to see a telescope? And it makes for an easier time when you can identify some of these major objects to what we call star hop to the next one. We'll talk about that in a little bit. If we were to go back here and we look at, I thought it was listed here, I'm sorry. Yesterday, they talk about there was a new moon. Yes, new moon on the 11th. Well, obviously the new moon is not a visible thing that you can see, correct? It is, the new moon is a moon that we don't see. And when I was preparing for this presentation, there was a challenge for tonight to try to catch the one-day waxing moon. So that's what I wanted to talk about really quickly. The stellarium was mentioned by Jeremy at the beginning. When you go into one of these apps that you can tell it your location and it knows your time, that is a wonderful tool because it would project where that object is so you can see it in live time. Jeremy,
Yes.
could you help me get back to stellarium for a second? I can see it here, but I don't know how to transition to it. I'm sorry, folks.
Let me see if I can bring it up. Not too much fuss. There it is. Okay. Could that be? All right. Do you hear us now? Let us know in the chat if you can hear us. Yes.
Yes, okay. All right, my apologies. What I was saying was I saw there was a challenge to see the one-day-old moon this evening, just after sunset. So with Stellarium, I am able to punch in the time. This representation of this field is fake. It comes with Stellarium. But nonetheless, I can zoom in and I realize how low to the horizon the moon is actually going to be. And I know where I normally go to view the sky, there will be no chance that I can see an object this low to the ground. And because of Stellarium, I can do that and not waste time to going out and looking for something that will be obscured by an object that I can't get around. The one-day-old moon is just this little tiny, less than 1% illuminated crescent. It is a beautiful thing to see when you can, but I realized I couldn't do it tonight. Well, we were cloudy anyway, right? So not that much of a loss. However, if I advance Stellarium to the next day, I zoom out a little bit, what's going to occur at nearly the same time, but the next day, is the moon is going to be a little bit higher in the sky. That is going to allow me to go back out the next day and see the two-day-old moon. And here it is. And now it's just a little bit more than 1% illuminated. And Jeremy, if I go to my presentation and then push transition, am I good?
If you want to switch back, we can do that.
Yep.
Back to the presentation. Let's bring this up here. In case we want to go back to Stellarium. There. Then you can just switch between the two as but you guys hit transition. Yep. And we'll bring that back up because it has to be full screen to show.
Okay.
Yep.
Okay. I do not know how to run this. I apologize, everyone. Okay. So here we go. We're watching for the moon. I hope everyone can still hear me. I've lost the page over here to see. My left-hand screen is
not showing. Oh.
Here we go.
Why is that so dark? That's not the right one. Now PowerPoint is giving us trouble. Okay. That's the right one. Okay.
Okay. So today's sunset was at 5:30 p.m. We realized that we couldn't see this. And here's the picture I had taken earlier from my home in the Stellarium program. But then over the next few days, the crescent moon will be higher each night and will become more and more illuminated, which is fun to see. If you see the terms waxing and waning, waxing is the amount of light illuminating the sun is increasing. Think about adding material, adding light. It's waxing. Then waning is when it starts to decrease. It's after the full moon in its 29-day cycle. All right. The thing I love about viewing the crescent moons, the waxing or the waning moon, over a full moon is the amount of detail you see in that mark, that line between what is dark and what is light. A full moon through a pair of binoculars, or especially with a telescope, is so bright it can actually be uncomfortable to see. These crescent moons make you feel like you can almost touch and feel the texture of the moon, and it's an amazing thing to see through any of the smallest telescopes. It is a grand thing to do. The website here are the two that I normally use to get data or to look for where to see the moon. So that doesn't probably need to be put in the chat because it's there on the screen, but inthesky.org and this drakescope.co.uk. That site here will allow you to print off free maps for each day of the moon cycle. So all 29 days has a photo representing the large craters that you can see at those little individual lines. Very cool place to look for some information. If we look back at that sky map, another term that you'll see is that the moon on the 18th will be at, I'm going to mispronounce this here. It's going to be at a point along its orbit where it is the farthest from us apogee. During that same time, on the 18th, the moon will be in conjunction with Mars. So, let's see, there we go. On the 18th, a conjunction means that two celestial objects are in the same right ascension. So if you think about a map and you think about longitude and latitude, these are coordinates that we use for objects in space. This is not a very close conjunction, but it still technically is. With a pair of binoculars, you could probably see the two objects in the same field of view, but any telescope, you wouldn't be able to see the two. But the cool thing is, on the 18th, not only can you be watching the broadcast from Copernic, but know that here Mars is, that nice little red dot that will be next to the moon, and a new NASA Perseverance rover is supposed to be landing that day. And that's going to be quite exciting to have a new vehicle up there running around. And these things are pretty big. It's the size of a small car, really. It's something like 10 feet long, 9 feet wide, and it weighs over 2,000 pounds. It is a big piece of kit that we're sending off to Mars. Looking at this on the 19th, we're almost at a full quarter, and that's when it would be right next to the Pleiades, or the Seven Sisters. Okay. Let's move out of the solar system and talk about some of the constellations and asterisms that we do see during the winter. An asterism is an unofficial grouping of stars. What's on the screen now, again, is an image from Stellarium, and it is the winter hexagon. It is connecting some of the brightest stars of the night sky together in this large hexagon shape. Inside of it, there's what they call the winter triangle as well. And these, again, are not part of the 88 recognized official constellations. For that, we go over here to the next photo, and we can see the individual constellations. The constellation Orion that I'm circling here, I think everyone can recognize so easily as the shape of a person. You have the three stars that make up the belt, you have the shoulders, it makes sense. This guy here next to it, these stars are so faint and they're so far apart. I don't know if I've ever tracked which ones are which with my eye, you know. This constellation here to the left of Orion is supposed to be a unicorn. I don't see a unicorn here, but it's okay. Kansas Major here below Orion is supposed to be a dog, and I got that. I can see that. And I want to share the images that made those constellations take the shape that they are. So here is supposed to be a hunting dog chasing after the hare. And if we go back, here is the hare, Lupus. One of the stories about Orion is that he is hunting this rabbit, and his two dogs Kansas Major and up here Kansas Minor, are along for the hunt for this rabbit, and it's getting away, and that's why it's under his feet and slipping away from him. Another story with Orion is that he's facing off to Taurus the bull above him, and his shield is there and his club is raised, and we'll see that in a photo coming up here soon. But Kansas Major is a notable constellation, probably because of this star here, Sirius. Sirius is the brightest star in our sky, the second brightest star, I should say, after the sun, right? It is a very brilliant, bright star that you can see, and that's why it becomes part of that winter hexagon. Kansas Major is home of Sirius, the brightest star in the sky. Yes, well, second brightest, we said, right? And it has other, some pretty well-known things inside of it. It has an open cluster. It is called the NGC 2359. Wow, that's a mouthful. It is also called Thor's helmet. And there's also a colliding spiral galaxy, or IC 2163. This picture on the left is the Thor's helmet. I know that this is, these both are Hubble images, something that we cannot possibly display here in our scopes, but looking at that photo, I could not include it. To me, this is the beauty of space, to be able to look at the sky and know in my mind what Hubble has seen and put those things together is amazing. The cool thing now with all the other data coming in, over back in Stellarium, you can turn on a filter to see where they have found exoplanets. So you can see the hundreds of exoplanets across the night sky as well through that program. Pretty cool stuff. This is supposed to be Kansas Minor. These two little stars here are supposed to be a dog. And here is the constellation. I'm not going to try to pronounce that because I will always mispronounce it, I am sorry to say. Kansas Minor is home of Procyon, one of the brightest stars in the night sky. And it's also one of the nearest stars to our own galaxy. It does have another spiral galaxy in that area. This constellation here that is the Unicorn had a very interesting event happen inside of it. There was a red supergiant that was what they call a variable star. It always kind of changed brightness. It wasn't that bright though because of the distance of the star. The star was very dim. A measurement that we use is called magnitude, and it was given at almost 16, which means it was pretty faint to see. The star is over 20,000 light years away from the Earth. But suddenly, there was an outburst that it brightened back in 2002 and was thought to be one of the largest stars discovered. The cause of the explosion is really unclear, but it resulted in what is called a light echo, which is a surrounding, I'm going to move to it, here we go. The surrounding dust is illuminated by the star that is behind it. It grew to an enormous size, but it did not expel its outer layers, which would normally happen during a nova or a star explosion. The star has increased in its temperature and luminosity, but it is now 15,000 times more luminous than our own sun and has a radius about 380 times the size of our own sun. And that's the sun, that's the star here down in the center of this. So it's amazing that it is not a nova, but nonetheless, it was a pretty crazy event, and it took the astronomy world kind of by surprise back in 2002. So again, looking here at this relatively empty area of space, let's go back again. to have something here do that surprised the world is kind of amazing to me. This is the home of red giants, though, because we all know about, Betelgeuse was thought to be ready to go supernova earlier last year, if we remember. Here we go. Okay, Gemini the Twins is one of the zodiac constellations, known mainly for its two brightest stars, Castor and Pollux. It is here is the line of the ecliptic plane, the sun passing through the Gemini makes it a zodiac constellation, as we said before. There are some nice viewable objects inside of here for a telescope as well. Messier 35 is there, the Eskimo Nebula, the Jellyfish Nebula will be found in there. So here are the twins sitting together. Again, this is a constellation to me. When I view it, I do see two people. You know, it's a very realistic object in the night sky. This on the left-hand screen that I'm circling is the Eskimo Nebula, and this one here on the right is what they call the Jellyfish Nebula. The Eskimo Nebula lies over 2,000 or nearly 3,000 light years away, and we think it was created about 10,000 years ago when a sun-like star, so a star like our own, used up all of its hydrogen in its core and started to cool and expand, glowing by 10 to hundreds times its original size, and it eventually expelled its outer layer, and it formed this what we call a planetary nebula. The center will eventually collapse and become a white dwarf. The relic was first spotted by Herschel back in 1787, and he nicknamed it then the Eskimo. And he did this because viewing it through the ground-based small telescopes, it resembled a face with a furry parka pulled up over top of his head. So this was supposed to be a face looking at you, and that was a furry parka, if you can imagine that. And yeah, I can do that. Aquila, he is referred to as the chariot, a person who drives a chariot. There we go. The constellation got its name because its major star form shaped similar to that of a pointed helmet worn by Roman and Greek chariot drivers, I guess I'm going to say, because I can't get it through my head. The constellation Capella, this contains Capella. Capella is here. It is the sixth brightest star in our night sky. It is also the site of this constellation is where the galactic anti-center is. The point in the night sky opposite to the center of our Milky Way, which is located in the constellation Sagittarius that we see in the summer. So during the daytime, here in New York State, above us are our summer constellations. And now, if we were to look up then, we're looking toward the center of our galaxy like we talked about. Now at night, if we were able to see this constellation, we are looking out and away from that center. And this is where that is. It is in this general area. Going to the next one. IC 405, or the Flaming Star Nebula, is an emission nebula found in Aquila, and it is encircled by a blue irregular star, and it casts ultraviolet radiation from the star, and it is absorbed by hydrogen gas, which was released, and the energy becomes visible to us. The mass of this is 23 times the size of our own star, and due to the size and temperature, it is approximately 60 times more luminous than our own sun. Again, these Hubble images are beautiful to see, and if you allow them to fill your imagination, that's part of why I enjoy looking up at the night sky. All right, Taurus. Now, the thing I want to talk about Taurus is all these constellations that we're talking about were part of that winter hexagon. So Aquila is up here just above, and it actually shares one star with Taurus the Bull. So here is the 1600 drawing of Taurus the Bull. So you can see where I'm circling here with the yellow circle is the bull's face, and obviously these lines coming up here are its horns. Off to the right side and above it is what's called the Seven Sisters, or the Pleiades, and is also supposed to be the symbol and or the Japanese would be Subaru. That's why the Subaru has a star on it for the car logo. Taurus lies underneath the ecliptic, so it's also one of the zodiac constellations. The Pleiades, or M45, Messier 45. Messier was a French astronomer, and he numbered these different objects as he was looking for comets, because in his day the optics weren't so well. Some of the things were harder to resolve. The Pleiades would not be one of those. The Pleiades, well, that's going to be my next one here. The Pleiades is a very easy to see grouping of stars. This here on the left is the constellation through an average pair of binoculars. There are 9 identifiable stars that have names, but there are many more stars underneath that. So the Pleiades is a very simple to see things. Some people call it the Little Dipper because it kind of looks like that too. I'm going to back up one page here and go back to this. And one more time. Right here, along the horn, of course I put my picture on top of it. Nope, there it is. This little purple square is called M1, Messier 1. So it goes back to the French astronomer looking for comets, and he saw a smudge. That smudge turned out to be this. Again, a Hubble image. This is a star that exploded approximately, or we believe, in 1054. Chinese astronomers named it the guest star, and that was nearly visible for 1 month during the daytime. The guest star they observed actually was the supernova, and we now call it the Crab Nebula. And there are some videos online that aren't too impressive to watch, but over the course of the years, they have taken multiple pictures of the Crab Nebula, and you can see like waves coming out of it. It's a very, very subtle thing, but they call it a pulsar wind nebula because they see that vibration as it moves through there. It's really kind of neat to see, but it's very subtle as well. So I didn't bother to include it on here, but it is extremely magnetic, and there's movement in there. It's a dynamic place. That type of event is what we thought was going to occur with Orion's Betelgeuse, but it resolved and it didn't happen. But that type of thing where we can see a supernova during the daylight has happened in recorded history, and it hopefully will again, and we'll be able to see that. All right, so here is Orion. Orion is my favorite constellation. It is one of the most easily recognizable things. It is supposed to be a hunter. Through Greek mythology, it represents a mythological hunter who is often depicted in the star maps as either facing the charging bull or pursuing after the Pleiades, which are supposed to be the Seven Sisters, or chasing after the hare, the constellation, with his 2 hunting dogs. The constellation Orion contains two of the 10 most brightest stars in the night sky. That's Rigel and Betelgeuse, and a number of very famous objects. The Orion Nebula, which is M42, the Horsehead Nebula, among others. We're going to go to the Orion Nebula. Again, this is a simple binocular view. This view you can almost see on a perfect night if you have very good vision. Simple pair of binoculars, and you will see this gas glowing whiteness around these stars. And here's the Hubble image that's false color, but it is a huge, massive area. Orion is lit up. If you could see in different wavelengths of light, almost all of Orion would glow red because of the energy and the different gases that are around it and that are being lit up by these furnaces that are behind here that are stars. This is known to be an area of where stars are being born. This is a stellar nursery. It's a very exciting spot that you can cover with your pinky alone in our night sky that people can spend hours and hours just discussing what's going on in that one picture. It is an amazing thing to see. And again, unfortunately, when we view it with our own eyes, we don't get to see these colors just because we can't process that much detail from something so far away. So knowing what is there through Hubble goes back to filling my imaginations, and I'm loving it. We're going to jump back closer to home and talk about the International Space Station. We're almost done. The International Space Station is a very cool thing to see. It is a very easy thing to see. You may have seen it before without realizing it, and we're going to talk about that really quickly here. This is the current crew. I don't have the names for all the whole crew. This is a in-between stage, so there's more people up there than normal. But going to this website here, heavensabove.com. Again, you will tell it your location at the top right part of the screen, and then on the left-hand column there is a simple ISS visible path. You click on it and it will tell you when you can see it. Obviously, the International Space Station is always passing overhead every 90 minutes or so. It needs to pass with it being illuminated from the sun for us to see it on the ground while we are in the darkness, while we're in the shade. So not every pass will be visible. And because of the timing of everything, we will not have an evening pass until March. All the other passes are all these early 4 to 5 o'clock. It isn't until March 16th that we have one that's in the evening. So anyone going to work early, you see a very bright object passing overhead, good chance that's it. But what you can do is go on to this website, heavensabove.com, pick on the ISS visible path. When you click the date here, it's going to print, or it will give you on your screen a star map, very similar to the one we started with at the beginning of the presentation, but it will be geared to show you exactly the path of the ISS. The direction of travel will be represented by this little arrow, and the time that it passes these objects will be shown. This path on the 16th is a wonderful path because it's crossing over the entire sky. On some evenings and sometimes it will just slip across the horizon and it's barely noticeable. So this is the 16th of March, 8:30 at night. It's going to cross right over the center of everything. It would be a very good time to view this if it's possible. And if it's not, there are these other dates you can try and find it. This gets really kind of confusing and in the weeds a little bit, but this is perfect and easy to understand, I think, by most people. Let's see, Jeremy, is there any questions or anything in the, is there any comments or anything going on?
We had some people mention some specifics about some of the constellations you were looking at, but no comments readily. If anyone has any questions, feel free to post them in the chat for a Q&A.
Let's see, if we go back. Yeah, so if we go back to this page here, I think I can just minimize that, make sure I'm back. Yes. So this is how all those constellations lined up. And let's see, Jeremy, if I can go back to Stellarium and I can just tell it to transition. Yes.
Looks like it's
Go here, boom. So let's ask if anyone has any specific questions about Stellarium. We'll turn off the cartoons for a second. You can turn off that false sky too, so we don't. Stellarium is a very powerful bit of free software that we love. This here is going to be telling us that there is going to be the possibility of a meteorite shower, I think. But it has a bunch of true life images too that can be turned on that are from Hubble. So there you go. Let me turn this back off. For those that are watching, let me turn that off so it's less. We're going to turn off the deep space objects. This one button right here is exoplanets. So if I back all the way out, looking up the night sky, and I say, where are there other worlds? Oh, man. It won't do it at that level. There we go. All those green dots are at least one other planet, and multiple of them are multiple planets. To me, that's amazing, and that's only from the areas that we've searched, and it's like every time we start looking at other places, we find more and more planets. And the last one of the rumors I heard was like, the theory is there's gonna be more planets than there are stars, and that's just boggles my mind, But let's see, if we zoom in here, here's the Orion Nebula, and it's that true kind of picture from Hubble that they put into this program. It is very much like Google Earth, but for space. You go to anywhere and any time. So the constellations, you could tell it to go back to a certain time, like when the pyramids were built or something like this. Or a lot of people love to what do the constellations look like on the day I was born or something like that. You can do that with this program. Satellites can also be tracked and viewable. The time can be changed. Oh, there goes a satellite there. And I didn't. Let's go back. See if we can catch that satellite streaking by. Oh, there's. Well, I'm not seeing it, but anyway, I start playing with this program and I get myself lost in the things it can do. But is there anything coming up?
Not just. Would you be able to show Mars? Just show how the
Absolutely.
planetary exploration works.
All right. So we have in Stellarium, when I left mouse click on a target and then hit my space bar, it will bring the target directly over. And yes, there are ways to connect this program to some of the computerized telescopes, and it will steer your telescope for you. But once that's been zeroed in, now I can just simply roll with my mouse, and I can go right into view the planet. What other, did you want anything else specifically, Jeremy?
No, just that was a good.
Okay.
Just to show one of the planets that is out
Yeah.
right now.
Now, because again, in the early morning, we will see other planets like Jupiter. I think we're just going to cheat and just go forward. Oh, we're locked on to Mars. That's why it's. Bring over this guy, and you can change the projection too of how this. You see the satellites are all zipping by. That's kind of cool to see. There we go. I wanted to pause. So the joys of here is, since we're here, obviously we have it where it doesn't show that it's daylight, right? This is Scorpio, our summertime constellation. This is Sagittarius. So that Milky Way galaxy, that is the galactic center. That's what we're looking into. And that is why it's so hard to see some of these things, just because that's the crowded city I was talking about. It is just a brilliant. The darker our skies are, the easier it is to see these things, the more and more this lights up, and it is amazing. But Jupiter and Saturn both have some moons that are fun to look at and easy to look at, and that's one of the common things we do here at Copernic. The cool thing is, this program will tell you where the different moons are. I'm going to go ahead and pause this, we're not moving. So here's Jupiter. This is a real-time location for these moons. Throughout the course of an evening, these moons will move, and these are what they're called the Galilean moons. These are the moons that were identified by Galileo. Obviously, there's I think 42 moons of Jupiter right now, something like that. But these are the 4 ones that you can see with the most common simple telescopes. Again, zooming right into Jupiter itself, you do not see the red dot, the big red storm. That's because it is not facing us at the moment. Jupiter rotates, I think it's once every 10 hours or 11 hours. It is a very fast spinning planet. So when we do look at it here at Copernic, let's say with our one of the scopes, we may or may not see that red dot because it is along its axial rotation, and then at other times we might be able to see it come into to view. It's kind of neat to see. We come on out. We go over here to Saturn. It too has several moons that are easily identifiable. The tilt of the rings is an accurate depiction of what it would look like as well. At different times of the year, now this is, no, not the year, but over the course of years, the presentation of, or the axis of those rings will change. Sometimes they're dipping towards you, sometimes they're a bit flat, but it's kind of neat to see that change. I saw Venus was here as well. Venus, because Venus is on the inside of our orbit, right, it is between us and the sun, it will go through phases similar to our moon. So here is nicely fully illuminated, but other times it will look like a waxing or a crescent or a waning crescent, and it's very similar to that, and all for all the same reasons. So we don't really get to see any detail on Venus, but there that is. Get out of that. Let's see. So someone said something about the red screen. Yes. So if you were using this with a computer outside at night, yes, definitely. You can turn on the red screen so you can not get yourself blinded by that light. Red light, like this, does not interfere with our ability to see things in the darkness. White light, screen light from your cell phone and all that will just blow your night vision away. And as you adapt your vision to darkness, it will be amazing the smaller, fainter objects that you can see. Let's see. Do you see anything else that?
No, I don't see any other questions. So.
I see someone talking about Aquila when it rises and lowers. Yeah. Let's see. I don't think it's too far away, time-wise. Let me just. This is, right here, this is one of the best things about this program. I kind of forgot something, so I can look time-wise and see how things are changing. I'm not seeing what I'm looking for. Anyway, but yes, it's a great program. I love using it. There are others out there, obviously, but it's pretty cool. Do we have the names on? So I see someone made I will not guarantee any of my pronunciations for anything, but here is the spelling of that one that was asked. Aquila. Agira, whatever. If there are no other questions or anything else, that's pretty much the presentation.
Yeah, I can switch over to the webcam and I'll close it out.
Let's see. I did have that one.
Oh, do you want to show that? Yeah, we can switch that quick.
Well, the presentation is no longer there. Oh, there it is.
Yeah,
Presentation, right?
Yep.
PowerPoint. It's not loading again, is it?
I think we need to go full screen on this one. Yep, and you can minimize that part. And now it's showing, yeah. There we go.
So that concludes my presentation. I'll turn it back over to Jeremy. Thank you for bearing with me and my poor pronunciations of some of those things. I hope you all enjoyed it. I love talking about astronomy. I love talking about simple naked eye observing the night sky, and we all do hope to see people back up here at Copernic as soon as this COVID thing is over and we can see people and talk to people and have you looking through our telescopes. And I'm going to turn things back over to Jeremy.
Thank you, Robert. So I saw a question pop up on the chat here. Someone is asking, Scott here is asking, do you guys still sell telescopes at the observatory? I don't think we have any for sale at the moment, but it is something we've done in the past, especially around our big observing events. Like Astrofest is a big one where our Astronomical Society do offer telescopes. But at the moment we are a little bit limited on that front. So occasionally, it's not something like where we source telescopes from somewhere though. It's really getting donated telescopes, fixing them up, and passing them off to be used elsewhere. So one thing I want to mention at the end here, if you didn't see it, start at the beginning, we do have our Winter Star Party coming up. That's what's being displayed on the screen now, in celebration of Nikolai Copernic's 548th birthday. So last year we just beat the start of the pandemic and whatnot. So last year we were able to have it in person, but this year we are going fully virtual, just like our other programs. So let me switch over to the webcam for a second so you can see me. There we go. So join us next week for the Winter Star Party. We're also on Thursday, on February 18th, we're going to be doing the watch party of the Perseverance rover. So if you have come with questions, we'll do our best to answer them. We'll be tuning into the NASA stream to see what comes about. We will during that watch party, we will know most likely that the rover has touched down, if in fact it does. Everything goes smoothly during those 7 minutes of terror, they call it. So that's Thursday. Friday is the Winter Star Party. We might have an observing session at the very end of that program. You can, of course, go to our website, copernic.org, for more details, or check out the video description. The link for that stream is already up. If you enjoyed tonight's program, we would greatly appreciate your support. So hit the thumbs up button on this video. Hit the subscribe button if you want to tune into more of our presentations and programs. We've been sort of, we're not doing the observing streams as often, both because it's been so snowy and it's just incredibly cold. They're fewer and further between, but we're going to do one in the next month at least. And then as things start to warm up again, we'll continue with those for sure. Someone's asking, where can I get that shirt? This one I think was from ThinkGeek, which is no longer in business, from what I understand. But I've seen them around elsewhere. Do a quick search on Google, and I'm sure you'll find a good few. Let's see. Any other questions that popped up here at the very end? No, lots of thank yous though. So no, thank you for tuning in. We're happy to continue these programs, again, sponsored by Broome Pediatrics. Okay, well, looks like that's it for the questions tonight. Thank you all for joining us, and we'll see you again for the Perseverance stream on Thursday.